Alright, hello class again. Today we're going to do the next two ways we could prove triangles being congruent. They would be ASA and AAS. So last time we talked about SSS, all three sides being congruent, and SAS, two sides and the included angle. Now we're going to work with when we have two angles and just one side. So like I said, we're going to start with angle, side, angle, and that is ASA. So that is if two angles are congruent, and the included side of the angles is congruent, then the two triangles are congruent. That would be for ASA. So if I have this triangle here, and then I have this triangle here, S, T, U, V, R, X, and I'm told that SU is congruent to X, V is congruent to T. That means that, and these things are congruent, that means that these two triangles are congruent. So we have to have these angles, and then the side that is in between these angles. So as for written, if I have angle S congruent to angle X, and angle T is congruent to angle V, and then ST is congruent to XV, whoops, then these triangles are congruent. S, T, U is congruent to triangle X, V, R. Then we have a little quick question for you guys. Let's say I have this triangle here, this triangle here, and this triangle here. I'm going to label parts as well. This will be this is A, B, and I'm going to mix it up a little bit and make this a Q. This is T, V, it's J. I'm going to make that a J now. J, V, and R, P, X, and let's try T this time. Alright, perfect. And we have different angles going to be congruent to different things. So angle A is going to be congruent to angle R, which is congruent to angle P. Angle B is congruent to angle J, which is congruent to angle X. That's color just used. And then AB is congruent to VR, which is congruent to PX. Which two triangles can I prove with ASA, angle side angle. Those triangles would be ABQ and PXT. Those are the only two triangles we can do with ASA. This one, we would need to have JR be congruent to PX and AB. Since it's over here, since it's this side here, we cannot use it for ASA. Now, but we can, on our next congruence one, we can use this one when we have an angle, and a side. So this is what we're going to do next. The next one would be angle, side. Before we get to angle, side, I do want to do one proof for this. So I'm given this and this. Let me just go like that. And this is D, E, A is in the middle here. I just drew it really poorly. C, and B. Now I'm in the textbook right now. I'm on page 236. I'm at the top of page 236. All right, so we are given this here. We're given all these things. Now, in the book, it says that CAB is congruent to DAE. And angle B and angle E are right angles. Sorry, that was loud. Are right angles. And that BA is congruent to AB. We need to prove these two things are congruent. I know that's really messy. I'm trying my best. Okay, so in order to do this, we just need to make a formal proof with our statement of reason. Number one, angle CAB is congruent to angle DAE, and that is because it is given. Number two, we could say that BA is congruent to AE, and that's also because it is given. Now, first we need to say that, and we could say angle B is congruent to angle E. We cannot say given for this one because it actually wasn't given, but what was given is that they are right angles. But we do know that all right angles are congruent, so we could say all right angles are congruent. And then from here, we could say that these two triangles are congruent. We have three different things, angle, side, angle, to make it congruent. So triangle CAB is congruent to triangle DAE. And that is from ASA. So that would be that proof right there. Okay, so now let's go into our next proof. Not next proof, next way to prove triangles. That is angle, side, angle. Angle, angle, side, I'm sorry. Angle, angle, side, abbreviation, AAS. This is when you have two angles that are congruent, and the non-included side is congruent to these triangles. So if two angles are congruent and the non-included side is also congruent, then the triangles are congruent. The important part for this is the same non-included side for this, and I'll give you an example for this. Alright, so I have this triangle here, and this triangle here. A, B, C, D, E, and X. Alright, so we're given that A and E are congruent, C and X is congruent. Now there are two ways that this can work. You could have angle, side BC is congruent to side DX. Or you could have this side and this side. The important part is this angle is opposite to this congruent side. This angle is opposite to this congruent side. So the side has to be opposite of the same congruent angle. So that's the important part. So the side must be opposite of the same congruent angle here. Alright, let's try one proof really quickly, and then we'll do a lot more examples in class. And in class, I think we're going to have a quiz at the end of this. Okay, so new page, new triangles, new names, S, T, U, W, X, and V. We have W congruent to T and X congruent to, this is supposed to be an S. Alright, and then we're going to have TU congruent to WV. Are these two things congruent? Now I'm taking, we're going to go through it. So we have angle S is congruent to angle X. Angle T congruent to angle W. TV is congruent to WV. Therefore, STU is congruent to triangle XYV. Alright, so basically this side is opposite of the same congruent angle. Alright, we're going to go through some more problems in